Okay, we have already seen the difference method or the telescoping series method. Okay, next we look at the series involving natural numbers. Here also we use the difference method. Okay, so let us look at the problem. Okay, these are the questions that involve series involving natural numbers. Okay, look at the question. Find the sum of the squares of the first and natural numbers. Okay, we already know we know the sum of first and natural numbers is n into n plus 1 by 2, and the sum of the squares we have already studied that result in plus 2. The sum of the squares of first and natural numbers is n into n plus 1 into 2n plus 1 by 6. Okay, now we are using this is a find the sum of the squares of first and natural numbers. So the series is s. Okay, first 10 terms only. Okay, so first 10 natural numbers, so I just denote it by Sn. So Sn is 1 square plus 2 square plus etc plus n square. It is the sum of the squares of first and natural numbers. And in terms of series, it can be written as the finite series sigma n is equal to 1 to capital N square. Okay, here we use difference method to find the sum. Okay, in case of series involving natural numbers, we use difference method. Here the nth term of the series is un is n square. And in the difference method, we have to express un is equal to f of n minus f of n minus 1 for some function f of n. Okay, here to do these problems, if we have to find the sum of the squares of first and natural numbers, you should know the function f of n. Here we are taking considering the function f of n as n into n plus 1. That is why I have already said you have studied the result sum of the squares of first and natural numbers is n into n plus 1 into 2n plus 1 by 6. So if you know the result, then f of n is taken as the numerator of that result. N into f of n is taken as n into n plus 1 into 2n plus 1. If you don't know that result, in case of the in this question, that is, if you are asked to find the sum of the squares of first and natural numbers, you should take f of n as n into n plus 1 into 2n plus 1. Anyway, you should remember this function f of n. Okay, so f of n is n into n plus 1 into 2n plus 1. Then f of n minus 1 will be, here in place of f of n, replace n with n minus 1. We obtain f of n minus 1. And simplifying, we get f of n minus 1 as n minus 1 into n into 2n minus 1. Then minus f of n minus 1, that is n into n plus 1 into 2n plus 1 minus this n minus 1 into n into 2n minus 1. N is common, so take outside and simplify. We get f of n minus f of n minus 1 as 6n square. Okay, we have to express un as f of n minus f of n minus 1. Un is n square, so un is n square, and from this expression n square is can be written as 1 by 6 times f of n minus f of n minus 1. So un is n square, that is equal to 1 by 6 times f of n minus f of n minus 1. To express un as f of n minus f of n minus 1, but here we got un as 1 by 6 times f of n minus f of n minus 1. So no problem, we can proceed with that. Okay, we are trying to express un like this, but we got un as 1 by 6 into, so it is a constant into minus f of n minus 1. So that is not a problem, we can apply the difference method. If un is, by difference method, if un is f of n minus f of n minus 1, then Sn can be written as f of capital N minus f of 0. Here un is 1 by 6 times f of n minus f of n minus 1. 1 by 6 is a constant, so Sn is also that constant 1 by 6 into f of n minus f of 0. And f of n is replace, we know small f of n, replace small n by capital N in that expression. So f of capital N is n into n plus 1 into 2n plus 1, and f of 0 is 0. In this expression put n as 0, so that is 0 itself. So Sn is n into n plus 1 into 2n plus 1 by 6. Sn is 1 square plus 2 square plus etc plus n square. So that is n into n plus 1 into 2n plus 1 by 6. Okay. Look at the next question. Find the sum of the cubes of first and natural numbers. Okay, if you are asked to find the sum of the cubes of first and natural numbers, so Sn is only finitely many terms. So I have written this as Sn 1 cube plus 2 cube plus etc plus n cube, that is equal to, in terms of series notation, sigma n is equal to 1 to capital N cube. Here nth term un is n cube. Here also you have to remember this f of n. Okay, You have to study for this question. If you are asked to find the sum of the cubes of first and natural numbers, you should take f of n as n into n plus 1 the whole square. Okay, you have to remember this. Then find f of n minus 1, that is replace n by n minus 1 in the expression of f of n. You get this. And find f of n minus f of n minus 1. Okay, you get 4n cube. Then un is n cube. And from this expression, n cube can be written as f of n minus f of n minus 1. Then by the difference method, we can write Sn is 1 by 4 times un is 1 by 4 times this expression f of n minus f of n minus 1. Sn is also 1 by 4 times f of n minus f of 0. And f of capital N is n into n plus 1 the whole square. And in place of n, put 0, then it becomes 0. So that's n into n plus 1 the whole square by 4. That can be written as n into n plus 1 by 2 the whole square. So the sum of the cubes of first and natural numbers is n into n plus 1 by 2 the whole square. But we know sum of first and natural numbers is n into n plus 1 by 2. So in n into n plus 1 by 2 is 1 plus 2 plus 3 plus etc. plus n. Sum of first and natural numbers the whole square. So sum of the cubes of first and natural numbers is equal to sum of first and natural numbers the whole square. Okay. Look at the third question. Sum the series sigma n is equal to 1 to capital N plus 1 into n plus 3. Okay. In order to do these types of problems, you have to remember sum of first and natural numbers, sum of the squares of first and natural numbers, and sum of the cubes of first and natural numbers. Sum of first and natural numbers is n into n plus 1 by 2. And sum of the squares of first and natural numbers, we have found out that n into n plus 1 into 2n plus 1 by 6. And sum of the cubes of first and natural numbers is n plus 1 by 2 the whole square. Okay, study these three quantities. Okay, in order to do problems of this kind, you have to study that results. Okay, in this problem, the nth term un is n plus 1 into n plus 3. And by simplifying this, we get that is equal to n square plus 4n plus 3. Okay, we have to sum the series, find the sum of the series. Okay, I have taken that series. Sigma n is equal to 1 to capital n plus 1 into n plus 3. N plus 1 to n plus 3, the product we have found out, that is n square plus 4n plus 3. So replace with that and give the summation separately. Okay, with that summation, separate the terms. Okay, it becomes that means put summation to each of these terms. It becomes sigma n is equal to 1 to capital N square plus sigma n is equal to 1 to capital N 4n plus sigma n is equal to 1 to capital N 3. Okay, that is sigma n is equal to 1 to capital N square plus in the second term 4 is a constant. So that summation depends, sum is equal to 1 to capital N. Summation varies over n. So this constant 4 can be taken outside. So plus 4 into sigma n is equal to 1 to capital N. Here 3 is constant, so we take 3 outside. So plus 3 into sigma n is equal to 1 to capital N, that becomes 1. If 3 is taken outside, then only 1 remains here. And look at the first series, sigma n is equal to 1 to capital N square. That means that is the sum of the squares of first and natural numbers. That is equal to, if we expand the series, it becomes 1 square plus 2 square plus etc. plus capital N square. That is sum of the squares of first and natural numbers. And we know the result, that is equal to n into n plus 1 into 2n plus 1 by 6 plus 4 into sigma n equal to 1 to capital N. That is sum of first and natural numbers. If we expand the series, that is 1 plus 2 plus etc. plus capital N. So that is sum of first and natural numbers. So that is equal to n into n plus 1 by 2. So this is 4 into n into n plus 1 by 2 plus 3 into n is equal to 1 to capital N 1. The summation varies over n. Okay, but here we have to sum the constant 1. So that means that is equal to, the summation is equal to adding this 1 n times. For n, sigma n varies from 1 to n. So each of the time we are adding this 1. So that is adding 1 n times. So that is equal to n itself. So if we add 1 2 times, that is 2. If we add 1 5 times, that is 5. So if we add 1 n times, that is equal to n. So plus 3 into n. So next, n is common in all these three terms. So we are taking n outside. So we get like this. Then we open this bracket, taking product. It becomes like that. Next we make 6 the common denominator. So multiply with 6 these three terms. Okay, then the denominator becomes common. So by simplifying, we get that is equal to 1 by 6 n into 2n square plus 15n plus 31.